In this tutorial, I'm going to show you guys how to create a non-blocking thread lock in Python. Now, we all know what thread locks are, at least I hope you do. If not, I have a good video on that I have linked to in the description below. Alright, so we have our threading module over here, we have our thread class from which we create threads, we have our lock class from which we're going to create a lock. Okay, now by default, this lock, whenever we call the lock.acquire function to acquire a lock, this is what we call a blocking function call. Or at least, it's not always a blocking function call, it's only a blocking call underneath one situation. There are two possible circumstances. One, in which the lock has already been acquired, and circumstance number two is that the lock is currently free. Okay, if the lock is free, this is not gonna block our program. But if the lock is currently busy, then it will block our program, because we all know that when we call the acquire function, the thread will halt its execution at that point until the lock has been acquired. So if I do this printout statement here, lock has been acquired, okay, and if I just move this into hold on, lock.acquire, let me just actually show you this. Okay, copy paste this into our function 2. Lock has been acquired by thread 2. Lock has been acquired by thread 1. Alright, and if I just put a time.sleep in here for 3 seconds, alright, we'll see some good output. And if I just run this code now, we can observe the blocking behavior. Okay, lock has been acquired by thread 1, but we don't see the statement for thread 2 until 3 seconds later, because this was a blocking function call, right? Thread 1 basically blocked the lock, or it didn't block it, it just, acquired the lock, and it used it for 3 seconds, okay, before releasing it. So function 2's lock.acquire call was basically halting the execution of our second thread. Now, this is okay for simple cases, but this could also be a problem. For example, let's say we have a very big application, a very large scale application, we have multiple threads, and performance is, essential. We need to keep our application optimized. Now, assume that we have two threads that are trying to access a shared resource, okay, like a variable. So thread 1 has got to the lock first, okay, he got there a second earlier, so he took the lock and has begun his computation with that variable. But let's say that thread 1 has a very long task ahead of him. He's going to take 5 seconds or 10 seconds or something like that, okay, and that's a lot of time. So thread 2 is now going to be waiting. And that's not a good idea. That's not a good idea in such a heavy application, or in some other similar application, that you make your thread wait for so long. Why not just make him do something else in the meantime, right? Why not just make him come back after a few seconds to check up, or do something else for 0.99 seconds and come back for that 0.001 second and check in later, right? We can do that, right? Yeah, we can. That's what the non-blocking call is for. So let's talk about that. I'm going to show you guys how to implement this, okay? Because making a lock non-blocking is actually extremely easy. All we need to do is turn the blocking parameter here to false. That's it. That's all we have to do. Or let me just put this inside function 2. Now, obviously, this is not a good idea, okay? It's not a good idea to do this unless you modify the rest of the program along with it. Okay, because imagine that our lock just continues and then it calls a lock.release, and that's going to cause an error, right? Because our lock was never acquired in the first place, right? So that's going to be a problem. So what we need to do is just modify our code. The thing is, the lock.acquire function actually returns true or false depending on whether the lock was acquired or not. So what we can do is something like this. If the lock was acquired, if this returns true, then we will execute this code. Otherwise, if not, just do something else. Okay? So watch. And let's assume this other task takes 1 second or 2 seconds. Actually, let's just go with 1. So I'm going to run this code now and observe the output. See, lock has been acquired by thread 1, so it's doing something else, and then the execution of our program finished. Okay, there wasn't really much to it. Now there's still one flaw in our current approach. I mean, the code is all fine, but I still think we can improve our code. And how can we do that? I want to add a while loop in here. Okay, and what I'm going to do with this code is say that, or at least what our code is going to do now, is that he's going to do something else for 1 second, and because there's a while loop, he'll loop back to this lock.acquire call. Okay, this is going to be an infinite loop that will only terminate once our lock has been acquired and released. Okay, so only when we are done, okay, thread 2 is done with its required task, only when this has been accomplished will we break out of this infinite loop. So let me just show you what this is going to do. I'm going to increase the time here to 5 seconds just so we can see some good output. Okay, let's begin. Okay, and now our code, you can see some problems here in the output. Let me just fix that first. I need to go just copy paste this line from some of my other code. Okay, this is a very handy way, because whenever you try and use print statements with multiple threads, there can be problems. So just use this print statement override over here. It's going to solve all your problems. Okay, it's a pretty thread safe way of printing to the console. All right, so let's try that again. All right, lock has been acquired by thread 1. It's doing something else, doing something else, doing something else, doing something else. Now, basically, we can see here that our program is much more efficient, because instead of wasting 5 seconds waiting for function 1 to finish, he did something else for the 5 seconds. All right, so that's like 5 times more efficiency. I don't think it's 5 times, but okay, yeah. So over here we can clearly see that this approach is pretty beneficial. The only slight problem here, that we can possibly run into is that between the time, that he may be doing something else, it's possible that some other thread ends up acquiring the lock. That could be a problem. But again, these are all things we need to take into account, and we design our application based on our needs and and our requirements. So yeah, that about wraps up our video on non-blocking thread locks. I hope you guys enjoyed it. If you guys are interested in more content like this, we have a video on the timeout parameter, which is also very interesting and very similar to blocking. It may be something that you may prefer rather than using this. Okay, so do check that out. Okay, subscribe to the channel, leave a like, leave a comment, let me know what you thought, and hopefully I'll get to see you guys in a later video. Bye then.